For today's video, I'll be doing video number 9B. A small block of mass M is hung from a rope and released. It begins to move downward, pulling a larger mass M along a horizontal surface with some kinetic friction given by the coefficient of friction. Derive the block's velocity just before it hits the ground in terms of the masses, h, coefficient of kinetic friction, and any other relevant constants. Okay, so the problem wants us to find the velocity of the blocks before it hits the ground. And the blocks would have the same velocity because it's tied to the same rope. And we're going to be using this equation, initial kinetic energy plus initial potential energy plus external work is equivalent to final kinetic energy plus final potential energy plus the change in thermal energy. And it wants us to find velocity. Okay, so we know that work is force times distance, and for force we know that there is friction. There's kinetic friction when the block is sliding, and so for kinetic friction it would be the coefficient of kinetic friction times the normal force, or force normal, which would be mass times gravity, big M times gravity, sorry, that's small m, but it's actually big M, times the distance, which is d. So the coefficient of kinetic friction times mg times distance. And we plug that in for work external. For kinetic energy, we know it's 1/2 mv squared. It'd be big M, plus there is no potential energy initially. It is 0. There's no potential energy, and then but there is external work, which is friction. And so you would do kinetic energy plus friction, which would be 1/2 mv squared, plus the coefficient of kinetic friction times mass times gravity times the distance, which equals the final, which there is no kinetic energy final, but there is potential energy final, and there is no change in thermal energy. So it would be equal to mgh, and m being lower m. And so what you would do is you would just solve for v, or velocity, and you would do all the calculations, and you would get v is equal to the square root of 2gh minus 2 times the coefficient of kinetic friction times big M times gravity times distance over small m. And so to check, that is using the masses, which we got both m, small m, and big M, h, which we have included, the coefficient of kinetic friction, which we also used, and any other relevant constants, which would be gravity and distance. And that's the answer. And this relates to what we've been learning in class, because we've been learning about the conservation of energy and mechanical energy, which mechanical energy is kinetic plus potential energy. And we've been learning about energy in class and its applications, and this is the problem using energy to solve velocity. Okay, thank you.